used batteries less than 1 volt. Don't throw it away. In fact, there is still some energy in the used battery. So how can we drain the last bit of power left in the battery? This is going to use the Joule thief circuit. Here's a battery at 1 volt only. It's powering an LED that needs two voltages to be turned on. Obviously, this little red light will definitely not be lit. What if we added circuitry to these devices? In the beginning, due to insufficient battery voltage, so the LED is off when the switch is pressed. This is how electricity flows. But because the current is increasing, inductance to prevent the increase of current, the induced voltage is left positive and right negative. When the switch is disconnected, current reduction, inductance to prevent the current from decreasing. The left negative and right positive voltages are induced. At this time, the battery voltage and the induced voltage can add up to light up the LED. We just keep closing and turning off the switch to keep the LED on. But it's very difficult to operate the switch manually. So we're going to use a transistor here. Who's going to control the transistor? Which brings us to our Joule thief circuit. When we close the switch, current flows like this. Since the current cannot be suddenly changed, so it's getting bigger slowly, so that when the transistor is turned on, the current flowing through O2 will gradually increase, but L2 in order to prevent the increase of current. So it will produce an inductive electric type with a positive top and a negative bottom. At this time, L1 generates magnetic flux in order to organize L2. So there will be a bottom positive, top negative inductive electric type. So the current generated by the right wing is superimposed on the current generated by the battery, further strengthening the transistor positive current. So the transistor saturates quickly, flowing through L2 after saturation. Current no longer increases. However, in order for L2 to continue to increase the current, an upper negative induced electromotive force and a lower positive induced electromotive force are induced. In the same way, L1 will induce an upper negative induced electromotive force, so the transistor turns off quickly. In this way, the battery voltage and the electric superposition generated by L to cause the LED to light up when the L2 electric plus the battery voltage is again less than the two voltages of the LED lamp. Go back to the previous steps again, and it goes in cycles. The LED will always be on until the battery runs out. Thanks for watching. Like, comment, share, and subscribe.